Hi everyone, welcome to another session. In this session, we will discuss another security model, which called Graham-Denning model. Graham-Denning model is a very simple model to understand for the CISSP exam. Uh, but in this video, I will also explain some disadvantages of this Graham-Denning model. They are very important. Um, to understand those disadvantages, why we can't implement this particular model in modern environment. But I will discuss those disadvantages of this Graham-Denning model. But first 5 minutes, I will quickly go through about this model just for the understanding purpose. How does it work? So the Graham-Denning model is an access control model that defines how subjects, users, processes interact with objects, file, resources in a system by using 8 primitive operation. It was designed to prove a structured way to manage access control in legacy operating system. In that, I think this model was designed back then in 1972. And that time we did not get those type of challenges which we have nowadays, right? In cloud environment, in data centers, we have some other challenges which cannot be avoided using this model. So there are some disadvantages, but we will discuss shortly. Um, so the primitive operation in the Graham-Denning model, as you can see, create object, a subject create a new object, file, resources, a user create example, a user or admin creates a new document, delete object, subject deletes, a subject deletes an object, user deletes a file, create object subject. So that means a new subject is created, system admin creates a new user account, um, delete object, a subject is removed, right? And imply, so this third column is for the examples, real-time examples, and employee account is deactivated. Operation read access, a subject reads objects data, a user opens a document, right? Grant access, a subject gives another subject access rights, a manager gives an employee permission to edit a report. Delete access, uh, a subject removes another subject access rights. A system admin revokes a user's file access. Transfer access, a subject transfers its access right to another subject. A user shares access with a new employee. So this is a quick summary of this Graham-Denning model, 8 primitive operations. As you can clearly see, they are very simple to understand. They are very simple to remember. But I just would like to highlight few disadvantages of this model. As we discussed, this model focuses on access control, defines who can access what in a system, right? Uses an access control matrix. We can call this is the matrix, right? So uh, mainly focus on matrix, right? So specify the permissions have over permission have over object. For instance, uses an access control matrix specify the permission subjects have over objects. So consist of eight primitive eight primitive operations, right? Defines how access right can be created, modified, granted, revoked, or transferred, right? That is the main focus. So now the problem which we have with this model, it is used in legacy system, works well in system with access control list, right? It is not suitable for zero trust, right? Not suitable for zero trust. So that is very important point, right? It is not suitable for zero trust. because it lacks dynamic access control and scalability. So uh, it is used in legacy operating system controls access using static access control rules, access control list used in routers, firewalls, and file permissions. Uh, every role-based system used in old Unix, Linux security models, right? Uh, and in firewall and routers, ACL defines who can access what resources. Similarly, similar to um, Graham-Denning access control matrix, right? So when we, let's say, when we create ACLs on the routers or firewall rules, uh, then they are predefined rules, and once they are added, right, on the routers, they um, without administration without admin intervention, those rules are um, not changed. They are predefined, they are not dynamic. Once their rules are in place, for instance, from one particular source to one particular destination on one particular destination port, so that access is allowed, and anyone can access, right? So that is kind of static entries, right? So therefore we can say why Graham Danick does not fit to modern security, because of zero trust and cloud. It is too rigid, as I said, uses static access control rules, while modern security needs dynamic real-time access controls. No context awareness. It does not verify user identity, behavior, or risk levels, right? Unlike modern zero trust models. Nowadays, we talk about zero trust because zero trust is very important. Um, the current challenges, the current security challenges which we have. So zero trust model is very important, and it is not scalable for cloud security. Therefore, it is not used. And in cloud environment, access must be role based or attribute based, right? Which Graham does not support. So modern security models use role-based access controls, assigns access based on users' roles, attribute-based access control, ABAC, grant access dynamically based on users' device location. Uh, so zero trust security continuously verifies access instead of relying on predefined permission. For instance, the example which I have already quoted, that when we add ACL rules or firewall rules, or on routers, then they are predefined permissions. So I mean, they can be monitored, but all the time administration intervention is required to check whether appropriate rules are in place, which rule needs to be added, which rules needs to be removed, and that is static thing, right? So it is not a dynamic thing. So therefore, this particular model does not fit in for zero trust security. So key takeaways: um, Denning is an early access control mm, model used in legacy system with ACLs, and what else we can we can say that it is. We can also say that Graham Denning a rule-based access control model, right? Rule-based ACLs, firewall rules. The Graham-Denning model follows predefined rules to manage access between subject and objects, right? These rules define who can create, delete, grant, transfer, and revoke access rights. Unlike dynamic models, ABAC, for example, um, unlike dynamic models, ABAC, for instance, role base. This ABAC is attribute-based access control. So hence Graham Denning is rigid. It does not change based on context. It is not role-based access control model as we have uh, discussed earlier. So I, in this model, administrator intervention is always required. All access control operations, create, delete, grant, revoke, transfer, must be manually assigned by an administrator. There is no automation or dynamic decision making. It relies entirely on manual rule enforcement. This makes Graham Denning a static model, unlike modern security models that adjust access dynamically, right? So I think model itself very easy to understand for the exam, for the CISSP exam, but there are few disadvantages or a few important things around this topic, like zero trust. They are also very important for us to understand, because when we work in in any environment, then we need to know what zero trust is. I will record a separate video for zero trust, but this if there might be a question related to zero trust and Graham Denning model, whether it fits in for zero trust, whether it fits with zero trust. So then we should know what are the disadvantages. Here, admin intervention is always required. So, but in zero trust, ABAC, attribute-based access control, role-based access control, and that can be achieved, with the next generation firewall, this role and attribute access control. So our legacy firewall, they where next generation, those firewall, they do not have next generation firewall feature. There we can always add rules, so predefined rules on routers, predefined rules, and we can say that this Graham Denning model fits to that type of approach. So that's it about Graham Denning model. I try to explain um, the disadvantage of this model, and as well as um, how these primitive operations works. Thank you so much for watching this video. Any question, comment, feedback, please share in the comment section.